Today we have to discuss Fourier transform and inverse Fourier transform. So first we have to define Fourier transform. Let f of x be a real function which is absolutely integrable. That is, integral minus infinity to plus infinity modulus f of x dx less than infinity and piecewise smooth. Then the Fourier transform of f of x denoted by f omega and is defined as f omega equal f of x equal to 1 by root 2 pi integral minus infinity to plus infinity f of x into e raised to minus I omega x dx. This is the definition of the Fourier transform. 1 by f omega equal 1 by root 2 pi integral minus infinity to plus infinity f of x into e raised to minus I omega x dx. The inverse Fourier transform of f omega is denoted by f inverse of f omega, that is equal to f of x, and which is defined as f inverse f omega equal 1 by root 2 pi integral minus infinity to plus infinity f omega into e raised to I omega x d omega. Inverse Fourier transform is defined as 1 by root 2 pi integral minus infinity to plus infinity f omega into e raised to I omega x into d omega. Then at points where fx is discontinuous, then f of x equal the average of the left and right hand limits. That is f of x equal half of f of x minus plus f of x plus. F of x minus is the left hand limit and f of x plus is the right hand limit. So the first problem is find the Fourier transform and inverse Fourier transform of f of x equal e raised to minus kx if x greater than or equal to 0 and k greater than 0 and equal to otherwise. So first we have to find the Fourier transform, and by formula the Fourier transform is given by f omega equal f of x, that is equal 1 by root 2 pi integral minus infinity to plus infinity f of x into e raised to minus I omega x dx. Here, the function f of x has e raised to minus kx for x greater than or equal to 0. So, the limit minus infinity to plus infinity becomes 0 to infinity. So, that is equal 1 by root 2 pi integral 0 to infinity f of x has e raised to minus kx into e raised to minus I omega x dx. So, that is equal 1 by root 2 pi integral 0 to infinity. So this can be written as e raised to minus kx into e raised to minus I omega x can be written as e raised to minus is common, then take outside minus into k plus I omega x into dx. So integrate this. And we know in integral of e raised to minus x is e raised to minus x by minus 1. Using that, this can be written as 1 by root 2 pi e raised to minus of k plus I omega into x divided by minus of k plus I omega limit 0 to infinity. So first we apply the upper limit infinity. So this equal 1 by root 2 pi. Then if we apply the upper limit, then we get the first term as e raised to minus infinity by minus of k plus I omega, and we know e raised to minus infinity as 0. So the first term is 0, 0 minus, then apply the lower limit, and we know e raised to minus 0 as 1. So 1 divided by minus of k plus I omega. So that is equal to 1 by root 2 pi into 1 by minus cancel. So we get 1 by k plus I omega, which is the Fourier transform. And the inverse Fourier transform, which is known as the Fourier integral, and which is given by f of x equal 1 by root 2 pi integral minus infinity to plus infinity f omega into e raised to I omega x d omega. So equal to 1 by root 2 pi integral minus infinity to plus infinity, and we get f omega. F omega is this one, 1 by root 2 pi into 1 plus k, 1 by k plus I omega into e raised to I omega x d omega. So this equal root 2 pi into root 2 pi, it becomes 2 pi. So 1 by 2 pi integral minus infinity to plus infinity e raised to I omega x divided by k plus I omega into d omega. So this equal 1 by 2 pi integral minus infinity to plus infinity. Then e raised to minus I omega x can be written as cos omega x plus I sin omega x divided by k plus I omega into d omega. So that is equal 1 by 2 pi integral minus infinity to plus infinity. So multiply the numerator and denominator by the conjugate of the denominator, that is k minus I omega. K minus I omega into cos omega x plus I sin omega x divided by k plus I omega into k minus I omega d omega. So equal to 1 by 2 pi integral minus infinity to plus infinity k minus I omega into cos omega x plus I sin omega x divided by the denominator is of the form a plus b into a minus b. So a square minus b square. So the denominator is k square plus omega square into d omega. Split the integral into 2. So this equal 1 by 2 pi integral minus infinity to plus infinity k into cos omega x plus I sin omega x divided by k square plus so this integral is 1 by 2 pi integral minus infinity to plus infinity k into cos omega x plus omega into sin omega x divided by k square plus omega square into d omega. This is the real part, plus I into 1 by 2 pi integral minus infinity to plus infinity k into sin omega x minus omega into cos omega x by k square plus omega square into d omega. This is the imaginary part. So that is equal to 2 by 2 pi integral 0 to infinity k into cos omega x plus omega into sin omega x by k square plus omega square into d omega, plus the second integral value is 0, because the reason is that in the first integral, integrand is an even function. So integral minus infinity to plus infinity can be written as 2 times integral 0 to infinity, and the second integral, integrand is an odd function, so the integral value is 0. So this equal 2 and 2 cancel. So this equal 1 by pi into integral 0 to infinity k into cos omega x plus omega sin omega x divided by k square plus omega square into d omega, which is the Fourier integral representation. And the second question is, find the Fourier transform of the function f of x equal to x for mod x less than or equal to 1 and equal to 0 otherwise. So mod x less than or equal to 1 means x lies between minus 1 to plus 1. So first we write the definition of Fourier transform. The Fourier transform is given by f omega equal f of x equal to 1 by root 2 pi integral minus infinity to plus infinity f of x into e raised to minus I omega x dx. So this equal 1 by root 2 pi integral minus infinity to plus infinity. Here the limit is minus 1 to plus 1. Integral minus 1 to plus 1 f of x is as x into e raised to minus I omega x dx. So this equal 1 by root 2 pi integral minus 1 to plus 1 x into e raised to minus I omega x is cos omega x minus I sin omega x into dx. So this is equal to 1 by root 2 pi integral minus 1 to plus 1 x into cos omega x dx minus I by root 2 pi integral minus 1 to plus 1 x into sin omega x dx. So in the first integral, integral minus 1 to plus 1 x into cos omega x dx, which is an odd function. So this value is 0. And the second integral, integrand is an even function. So the second integral can be written as 2 times integral 0 to 1. So this becomes I divided by root 2 pi into 2 times integral 0 to 1 x into sin omega x dx. So this equal minus I divided by root pi. So this 2 can be written as root 2 into root 2 and 1 root 2 cancel. So it becomes minus I by root pi into root 2. Then into integrate this. First function is x into and integral of sin is minus cos omega x by omega. then minus derivative of x, that is 1, into integral of this one, that is minus into integral of cos is sin omega x by omega into here 1 omega, so it becomes omega square, and limit is 0 to 1. So this equal minus I into root of 2 by pi, root 2 by root pi, it can be written as root of 2 by pi into minus x into cos omega x by omega, then here minus into minus becomes plus, plus sin omega x by omega square, limit is 0 to 1. So that is equal minus I into root of 2 by pi, then into, first we apply the upper limit 1, so minus 1 into cos omega by omega plus sin omega by omega square, then minus apply the lower limit. So the first term contains x, so we apply 0, then the first term is 0, and here sin 0, 0. So we apply the lower limit 0, the value is 0, so minus 0. So that is equal minus I into root of 2 by pi, then into minus cos omega by omega plus sin omega by omega square. So that is equal minus I into root of 2 by pi into, then here the LCM as minus omega square. So numerator becomes minus omega cos omega plus sin omega. So take a minus sign in the bracket. So minus into minus becomes plus I into root of 2 by pi. Then the first term becomes omega cos omega minus sin omega divided by omega square. Okay.